Hey folks, welcome to this episode on molecular formulas. Here we're going to be doing another example on how to calculate empirical and molecular formulas. Quickly, please do me a favor, like and subscribe to this channel. Only about 5% of people watching these videos are subscribed, so that would really help me out to get these videos out to more people and help them through their chemistry journey. So let's go through this one here. We have this crystalline asbestos, and it has a percent composition by mass of magnesium, silicon, hydrogen, and oxygen. The molar mass of this compound is 520.8 grams per mole. Let's determine its molecular formula. So the first step here is to calculate our empirical formula. And the first thing that we need to do is convert these percentages into masses. So what we're going to do is we're going to assume 100 grams of this sample. This will allow us to easily convert these percentages, which are out of 100%, into grams. So let's break up our elements: magnesium, silicon, hydrogen, and oxygen. And so if we have 28.03% of magnesium and we have a sample size of 100 grams, that's going to equate to 28.03 grams of magnesium. The same for silicon: 21.60 grams of silicon, 1.16 grams of hydrogen, and 49.21 grams of oxygen. So now that we have our masses of each of these elements, the first thing that we need to do is convert these into moles, and we need our molar mass to do so. So we want to get rid of the unit of grams, and we want to be left with moles, and the unit that has both of these units inside of it is molar mass of the particular element, magnesium. So if we flip to our periodic table, we'll find that magnesium has a molar mass of 24.31 grams per mole. And we're going to do the same thing for each of these other elements. So silicon is 28.09 grams per mole. Hydrogen is 1.01 grams per mole. And oxygen is 16.00 grams per mole. Now, when we do this, the grams will cancel out and we'll be left with moles for each of our calculations. So let's take a look and see what we get from each calculation. For the first one, we have 1.1530234 mole of magnesium. The next one, we have 0.7689569 mole of silicon. Here we have 1.1485148 mole of hydrogen. And here we have 3.075625 mole of oxygen. Alrighty, so now what we're going to do is we're going to look for the smallest mole value and divide all the values by that smallest one. And you can see that it's going to be 0.76. So what we're going to do is we're going to take that number and divide every single one of these by that value so that we can get a ratio. And I'm going to do the same thing for all of these, but I'm just going to put quotation marks so I don't have to rewrite this number every single time. What you'll notice is that we're, again, dividing moles by moles. So our moles will cancel out and we'll be left with a unitless number, which is exactly what we want. Our subscripts don't have units. So if we look at the first calculation, we will calculate this out to be 1.499464. Now, this cannot be easily rounded up or down. Remember that our range is, let's say, for example, we're looking at 1.01 to 1.09. We could round this down to 1. And if we had 1.91 to 1.99, we could round this up to 2. But 1.49 does not land in these ranges, so it can't be rounded to up or down. However, what it could be rounded to is something that looks like one of the other options that I discussed in my decimal video. If you haven't watched that video, please take a look at the playlist and you can see that video to describe what's going to happen next. What this looks like is 1.50. All right, now, for those of you that know what's going on, you'll understand the next step, okay? If not, just stay tuned and we'll talk about the next one. Now, this number divided by the same number is going to be equal 1. And here, what we have is we have 1.493601. So once again, we cannot just simply round these up or down. This is going to look like 1.50. So once again, we'll talk about what we're going to do here. And for this one here, we're going to get 3.999736, which does fall into the range of rounding up. And so this is going to be 4. Now, whenever we have these decimals, we can't simply just round them. We're going to have to multiply by a factor in order to get them into a whole number. Now, 0.5, if you want to turn 0.5 into a whole number, all we have to do is multiply by a factor of 2. But what we're going to do to one, we must do to the others. And so we're going to multiply all these values by 2. And what we get is 3 here, 2 here, 3 here, and 8 here. And now we have found the subscripts for our empirical formula. So let's take a look. Magnesium has a subscript of 3. Silicon has a subscript of 2. Hydrogen, subscript of 3. And oxygen, a subscript of 8. So let's create our empirical formula. So our empirical formula is going to be magnesium 3, silicon 2, hydrogen 3, and oxygen 8. Perfect. There's our empirical formula. Now we're looking for our molecular formula. So what we have to do now is we have to compare the mass of our empirical formula with the mass given in our question. So our question stated that our molecular formula has a mass of 520.8 grams per mole. So we have to figure out this mass and see how it compares to that one. So to calculate the molar mass of our empirical formula, all we're going to do is we're going to take 3 times the mass of magnesium, plus 2 times the mass of silicon, plus 3 times the mass of hydrogen, and plus 8 times the mass of oxygen. If we calculate this through, we will get a molar mass of 260.14 grams per mole. All right, so that is our molar mass of our empirical formula. So now to compare them, what we will do is we'll take the molar mass of our molecular formula found in the question and divide it by the molar mass of our empirical formula that we just calculated. That mass again is 520.8 grams per mole. And here we have 260.14 grams per mole. And because we're dividing by the same units, these units will cancel out. We'll get a unitless number. And if we calculate this through, we'll get 2.00, which we round to 2. So now we have this factor that we can multiply the subscripts of our empirical formula by. Remember that our empirical formula is Mg3Si2H3O8, and we're gonna multiply all of these subscripts by this factor of 2. And this will allow us to calculate our molecular formula, and our molecular formula is going to be Mg6Si4 H6 and O16. And that is going to be our molecular formula of this particular type of asbestos. Now, this type of asbestos makes up about 95% of the asbestos found in the US and Canada and is considered to be a very bad human carcinogen, which is one of the reasons and one of the leading reasons of mesothelioma, which is a type of lung cancer. If you found this video helpful, please like and subscribe. Please watch the other videos that might be suggested to you or anyone's down the playlist. Please, again, thanks very much for watching, and we'll see you on the next one.